It has become somewhat of a tradition on this channel to bring out the Grinch once a year every Christmas. This year is no exception, so in today's video it's on the bench again. Let's see if we can fix it this year. The Grinch is a strange and rather rare machine from IBM, manufactured for just a few months at the end of IBM AT's lifespan, right before they launched the all-new IBM PS2. I got this IBM 3 years ago for Christmas as a fun project to overclock the crap out of it and see if we can make it beat its big brother, the IBM AT. Unfortunately, on power up, the 5154 EGA display blew out the magic smoke. We replaced the blown up Vima branded safety cap, but it still wouldn't work. We then did some troubleshooting and found one completely dead electrolytic cap. So we replaced all the caps in the display, but it still wouldn't work. We then did some more troubleshooting and found 2 dead resistors. So the display is now working. We have also restored the keyboard in a separate video. I'll put all the videos in the playlist and leave a link below if you want to watch the other videos too. The 5162 was even worse. It just gave us a RAM error and wouldn't post. We have replaced the RAM with tested sims, but it didn't help. Unfortunately, in our previous attempt to fix it, things went from bad to worse. We used to get a RAM error on the display here, but now it's completely dead. It's not doing anything at all. We have already checked all the basics, but since the board is completely dead now, we need to go back and check again. So let's start with the postcard. Okay, the board is stuck at FF, but we have all the voltages. We have a clock. Let's reboot again and check reset. Yeah, the reset LED lights up briefly and then turns off again. So that is working, but I don't think we have a ready signal. Let's turn that thing off again and turn it on. Yeah, I think that LED needs to light up. Let me check. Okay, I checked and that is correct. The way this card works is that the ready LED should light up and stay on. And it didn't. So I checked on the board and the chip responsible for it is this guy here. So let's have a look at it with a scope. Well, in that case, I think we should open up a Christmas present from FNIRSI. So this time they have sent me a 2D15P. It's a 3-in-1 2-channel 100 MHz phosphor scope meter. Let's see what this guy is. Okay, it's a bit larger than I thought. Okay, let's see what we've got here. It kind of looks like a proper scope, but about half the size. Yeah, it kind of looks like a regular scope, but much smaller. I also got some stuff in this box. So first we have a manual in Chinese and English. That looks pretty good actually. USB cable, probably for charging. And then we have some pretty standard looking probes here. I think I already have a bunch of these. They have worked well for me. And then we have 2 sets of leads. Okay, so I messed around with the scope for a bit, and it seems to be a pretty good scope. So I have a big fancy scope, but I tend to use these small ones instead. For a couple of reasons. So first of all, it has a battery, so no cords needed. Secondly, they are really small and easy to move around on the bench. And especially since I make YouTube videos, I tend to move around quite a bit on the bench. And a small scope like this is just more practical. And thirdly, my big fancy scope takes forever to boot. But this little guy here turns on in a few seconds. It also has these really neat flip out feet. So I can keep the scope at a perfect angle. The only thing I don't like with any modern scope is the highly reflective displays. But every scope I have tried so far has the same issue. So they act basically like a mirror, and it's kind of annoying. But this is something all modern scopes seems to suffer from. It also has a pretty good multimeter, and then it also has a basic built-in frequency generator. So if you only need the basics, it's probably going to be good enough. The main thing I really liked when testing it out is the touchscreen, which makes using it really quick and simple. And the only setting I had to do was to go to menu and then set and then volume. And I turned the beep down to 5% because it was set to 100, which makes it incredibly noisy. In fact, I think I'm going to turn it off completely, because I don't really need the scope to beep every time I change something. That was all the settings I needed to do. So I'm not going to do a regular review of this scope. Instead, we're going to use it and see if it can help us repair this motherboard. I should also mention that it has a small fan at the back here. It's not a noisy fan, but no fan at all would have been perfect. Yeah, so aside from the reflective display, I don't really have any complaints at all. But as I mentioned, this is an issue with all modern scopes. I'm not aware of any modern scope without a highly reflective display. Okay, so this guy here is the D82-284, and it's generating the ready signal on pin 4. So when we turn the machine on, it should go high and then low. Okay, so let's see how it behaves. Well, kind of did. Let's try that again. Well, I wasn't expecting all those spikes, so I'm not sure if it's behaving normally. I was expecting it just to go high and then low again. So I'm not sure here. Well, since this chip is generating our ready signal, it only makes sense to start this troubleshooting by replacing it with a known good part. Here goes. No, it wasn't that easy. Still no ready signal. But now it's actually stuck at 1F. When we did the previous repair attempt, we had really crappy schematics. It was such a bad scan, we couldn't really read any pin numbers. But since then, one of my viewers has helped me to find a really good scan. So on the first page, we actually have our D82-284 here, U79. And our ready signal is at pin 4 here. And the first component it goes to is R19. It looks to be a pull-up resistor. And it's also marked 910. So presumably a 910 ohm resistor connected to the 5-volt rail. So let's check it next. Okay, I found it on the board and it's tucked away behind the Mathco here. So let's test the built-in multimeter. And my leads are about 0.3 ohms. So if we measure from pin 4 to the resistor, we've got 0.4. So basically 0 ohm. And on the other side of the resistor, we have 0.9K, so about 910 ohms. So that looks right. Now let's switch it to DC voltage and turn the power supply on. And if we measure to ground, we should have about 5 volts, and we do. Okay, so that resistor is pulling pin 4 to 5 volts, as intended. And next to tray splits here, then continues to the Mathco. The Mathco isn't really needed, so we can just remove it. Okay, let's try the board again. Now I think it's posting. It's not stuck anymore. We still don't have a ready signal, but the board is definitely doing stuff. Oh, the error is back. Wow, so that was a bad Mathco. This is a first for me. But hey, apparently these guys can go bad. Okay, awesome. So we are back at only having one fault now. So that's good. And here's that error I mentioned. So for whatever reason, this board thinks the RAM sims here are bad. But they're not. They have been tested in another board. And we have also tested the board with a different set of sims. So we know for sure that these are good. The ready LED still didn't light up. So I'm not sure what to think here. Maybe there is a compatibility issue between the postcard and this motherboard. Okay, I checked, and that LED apparently is only used by the card when it's connected to a PCI slot, but not when connected to an ISA slot. So we can actually ignore that LED. But it's kind of funny that it actually helped us to find the first fault on the board. I guess sometimes all you need is some luck. Okay, so let's see if we can fix that RAM issue. So we have already checked all the pins on the SIM modules, and all the data, address lines, RAS and CAS were all good. So the only thing we really know here is that one of the chips between the CPU and the RAM is either faulty or marginal. Okay, so there's no point in checking with the scope again, since we know all the signals look good. So let's instead check where they are connected to the board. So on this page we have the two SIMs here, and they are connected to U107, 4 and 6. And they are on the edge of the board here, so U104, 6 and 7. We have already tested these two guys here, but not this chip here, because I didn't have one when we did the previous repair attempts. But I do now, so let's swap it. I'll start by adding some fresh solder to all the pins. By the way, we have replaced all the tantalums and some of the chips on this board in previous attempt to fix it. I'll mention them as we go. But that is why we have some sticky flux on the board. I obviously don't wash the board until we're done. And every single pin on this board is bent. Extremely annoying. So before we can remove this chip, we have to unbend all the pins with the desoldering needle. It's funny how some of my favorite tools are also the cheapest tools I have. Like these desoldering needles. They make unbending pins so much easier. So these guys are small enough to go into the through hole. And they are hollow, so the pin can go inside. Really awesome tool. Motherboards this vintage scratch very easily. So I'm going to be very careful and not push too hard with the desoldering gun. Okay, all the pins are nice and straight and free from solder on the other side of the board, but they are still stuck to some solder on this side. So let's add some heat with a rework station. I'm being a bit careful here because we are very close to the ISA slots. And here's our suspect U106. I'll install a socket instead of that chip. This guy is a dual 4-input multiplexer. By the way, this is a 74F series chip. Don't know if it matters, but my spare chip is also 74F. I think that F stands for very high speed. Here goes. Ah no, still the same error. RAM error, FFFE. So next we have this LS125 here, U21. This gate up here is the same chip. I had one of these in our previous repair attempt, so this chip is checked too. We have also checked these two resistor packs here, RN1 and RN2. So everything on this page has been tested, except for these guys here, R7 and R8. But they're just marked XX. So let's check these guys out next. Okay, I found them on the board, and they're hiding away here, close to the RAM chips. And they are all white, so I suspect these are just 0 ohm resistors. Let's find out. So remember, my leads are 0.25 ohms. And these guys measure 0.25 and 0.29. So these are indeed 0 ohm resistors. And they seem okay. Okay, so every single component on this page are now tested. And from here on we can go in many different directions. So let's just pick a direction and see how lucky we are. So let's grab all the connections here going to page number 6. And that brings us here to U95 and U48. And these are 74F245s. These are quite prone to fail. So this should be a good next step. Okay, I found them on the board. So we got U48 here and U95 up here. Well, we have a bunch more of 245s on this board. So perhaps I should put them all in sockets. Even if they're good now, they are quite likely to go bad in the future. So maybe I'll put them all in sockets, since I have the board on the bench. Well, that took a while. Apparently this board has no less than 9 74 245s, but now they're all in sockets. I also think I forgot to mention, we have previously tested the CPU, the D82-284 and the D2288, the real-time clock chip, U8 and U9. We have checked all the crystals, the BIOS chips, the 2 SIMs and the RAM on the motherboard. And we have replaced all the tantalums. Now let's continue. I did a quick test with all the chips installed on the motherboard, just to make sure I didn't mess something up. And the board behaves exactly as it did before, so we're all good. Now let's remove U48. This guy is a 74F245. I don't have an F245, but I have an ALS245. So not an ideal test. But at the same time, I don't really see why this board would require F series. But who knows, maybe it does. Here it goes. No, that's not our bad chip, unfortunately. And our board loops between FF, DD and FE. And it just keeps looping. Okay, let's go for U95 next. Here goes. And unfortunately no. Still the same error. And again, this was an F245. And I replaced it with an LS245. Okay, let's go for U70 next. This guy is an LS245. So this is a proper replacement. Here goes. Okay, interesting. I actually have a different RAM error now. Instead of FFFE, we now have FCFE. Okay, so something changed. So now I wonder if we have multiple faults. So how about if we leave that chip in and put the two 74F chips back on the board. Okay, the fast U48 and U95 are back on the board, but I left the new U70 on the board. Here goes. Okay, now we're back at FFFE. I'm not sure what to make of this. Okay, let's go for U82 next. This guy is an ALS, so unfortunately not an ideal replacement. But let's hope for the best. Here goes. Nope, still FFFE. No change at all. Okay, I put the fast U82 back on the board and replaced U88. And unfortunately again, it's an LS chip instead of an ALS. Here goes. Nope, still FFFE. Okay, let's go for U97 next. And no change at all. Crap. Okay, so how about U98? No change at all. So how about U99? Nope, no change at all. And our last chip in a socket is U100. That's an F245 again. Fingers crossed. No. Oh crap, that sucks. Well, I'm not quite happy with that test, so I went through some finished projects. And I found a couple of ALS chips and one F chip that we can borrow to do a better test. Okay, so with 4 correctly replaced chips on the motherboard. Let's try that again. No, at least it's not one of those 4 chips. Okay, I put those chips back on the board. Now let's test these guys. No, still no difference. Okay, the last two, U99 and U100. Fingers crossed. Oh man, this sucks. What a Grinch. I was pretty sure it was a 245, but apparently I was wrong. Well, Christmas is over for this year, and this is going to be my last video for this year. Next I'll stash up with a reasonable pile of 74F and 74 ALS chips, and then we'll have another go. Suggestions for things to test are always welcome. And on that note, I'll end this video by wishing you all an awesome 2026. Thanks for all the support during 2025. It's been good fun to make all the videos and see the channel reach 20k subs. Before you leave, like, subscribe, leave a comment and consider joining me on Patreon. All that YouTube stuff really helps to grow the channel. And I'll see you guys again next year.